Start is. Hi students, I am going to start an interesting topic today that is called as retrosynthetic approach. So what is meant by retrosynthetic approach? Retrosynthesis, the word retro means backward and synthesis is synthesis. So if we don't know the synthesis of an unknown compound, we just break it into small parts and then go to the smallest part and then start the synthesis from it. So that means since we are breaking it into small particles and starting from that simplest particle, this term is called as retrosynthetic analysis or retrosynthetic approach. Normally, why do we carry out retrosynthesis? There are several questions to be answered. Whenever we carry synthesis, we come across several questions in our mind. Is there a shorter synthesis path to my target molecule? Or how can I synthesize this compound? Can we increase the yield of this process by choosing another synthesis strategy? So questions of this type arise in our mind. So in order to answer these questions, we have to consider retrosynthetic approach. Now the contents which we are going to study in this chapter is what is disconnection approach, the definition of disconnection approach, guidelines for choosing disconnection, functional group interconversion, regioselectivity, stereoselectivity, stereospecificity, and chemoselectivity. How this idea of retrosynthetic come? Professor E.J. Corey originated the term retrosynthetic analysis and was the first to state its principles formally. And E.J. Corey is the professor of Harvard University and he was awarded the Nobel Prize in Chemistry in the year 1990. Now let us see the definition of retrosynthetic approach. The process of breaking down of the target molecule into available starting materials by disconnection and functional group interconversions is known as disconnection approach or retrosynthetic analysis or retrosynthesis or synthesis in the backward direction. This is the process of the synthesis design which starts with the product and works backward towards the starting material. Now, what is disconnection? It is an imaginary process, a reverse of a chemical reaction. It breaks the bonds in the target molecule to give a structure of new compound from which target molecule can be made. Now, how do we design a synthesis? While designing a synthesis, first of all, we have to recognize the functional groups in the target molecule. Disconnect by methods corresponding to known and reliable reactions. Then third one is repeat as necessary to reach available starting materials. Then how do we carry out effective synthesis? Effective synthesis can be carried out by an understanding of reaction mechanism, a working knowledge of reliable reactions, an appreciation that some compounds are available, and an understanding of the stereochemistry. So, by keeping all these points in our mind, we can carry out an effective synthesis. Then, how do we carry out the actual synthesis? Write out the plan according to the analysis, then add reagents and reaction conditions. Modify the plan according to unexpected failures and successes in the laboratory. For designing synthesis, back knowledge is required. An understanding of the reaction mechanisms, a working knowledge of reliable reactions, a knowledge of some compounds that are readily available, an understanding of stereochemistry. Now, let us see the definition of some of the terms used in synthesis. Number one, target molecule. The molecule which is going to be synthesized is called as the target molecule. Then the term disconnection. It is an imaginary bond breaking corresponding to the reverse of a real reaction. Next, the term functional group interconversion. The process of interconverting one functional group into another during retrosynthetic analysis. Next, synthesis backwards. What is it? It is a process of breaking down the target molecule into available starting materials by disconnection or functional group interconversion. Then, how do you symbolize retrosynthesis? An arrow is represented. It is a double line arrow used to indicate the reverse of a synthetic reaction. Then let us look at the term synthon. A synthon is an idealized fragment. It is usually a cation or anion resulting from a disconnection. Synthetic equivalent, a chemical reaction, a chemical compound or a reagent carrying out the function of a synthon is called as a synthetic equivalent. Then let us see the common synthons and equivalent reagents. We have the list of the common synthons. Some are having positive charge and some are having negative charge. So positive charge cations and negative charge anions both are listed in the given slide. Now let us look at the word chemoselectivity. When the molecule contains two reactive groups and we want to react one of them but not the other, the following are the guidelines. Guideline 1. With two functional groups of equal reactivity, the more reactive one can always be made to react alone. For example, this is a paracetamol and there are two functional groups NH2 and OH. So only one can be made reactive and it can react alone. Guideline 2. When one functional group can react twice, the starting material and the first product will compete for the reagent and the reaction will be successful only if the first product is less reactive than the starting material. Then guideline 3. Protecting group usage. Example, synthesis of thiols. Direct alkylation of H2S is not a good one as this product is as reactive as starting material. So thiourea 9 is used as a masked H2S equivalent and the thiouranium salt being unable to react further and easily hydrolyzed to the thiol. Then guideline 4. One of the two identical functional groups may react with one equivalent of the reagent using the statistical effort. This is an unreliable method, but if successful, it avoids protecting groups or roundabout strategy. Guideline 5. A more reliable method with identical functional groups is to use a derivative which can react only once. So the example is Friedel-Crafts reaction is also effective on anhydrides and goes only with cyclic anhydrides. So that's all for today and we will continue the topic stereoselectivity in the next class.